Okay, so we are doing 3.7. Not fuzzy to anybody else but me. It's like extra fuzzy. What are we doing here? Get your life together, camera. Okay, that's better. Okay, 3.7. We're going to learn about step functions and piecewise functions. Piecewise is one word. So step functions and piecewise functions. Your homework is split into two sections. The first section is step functions. The second section is literally piecewise functions, okay? So we're going to do both. Now, a step function, what it is. A series of line segments period. That's what the picture looks like. Also known as an greatest integer function. Period. That's its other name. This is what the function looks like. F of x, so that hasn't changed because it's a function. That's why we're writing f of x, right? Now, what a step function symbol looks like. You know a bracket, right? I call it a double bar bracket. So it looks like a normal bracket, but it's going to have like an extra line in it. We all see that? And then your function goes inside of it. So like we're just going to put x in there for now. And then we're going to close it. So a bracket with an extra line in it. That's a step function. Okay, what this means. Okay, so if I have the greatest integer, that means the symbols, of 6.8. It's asking you what is the greatest whole integer, right? Because an integer is a whole number that goes into that number. 6. That is our correct answer. Okay, so you technically will round down because it's the number that makes it. So you can't round up. It's not like decimal places, okay? Then real quick, thinking about negatives, right? The greatest integer of negative 3.9. It doesn't really matter what it is. Negative 3 point something. This one's like backwards because it's negative. What's the greatest whole number that makes negative 3.9? It is negative 4. So with positive numbers, you go down. Technically, negative numbers you're going down too, but it feels like you're going up because the number itself gets bigger. So you're always rounding down, but down for negatives means that actual whole number gets bigger. Does that make sense? Think about the number line. You're going backwards, moving to the left each time. That by itself, does that make sense? Okay. Now, the domain of a step function is always all real numbers. That's the answer. Did I show you the symbol for all real numbers instead of having to write all those words? No. The symbol is a capital R with a second bar. It's a double, I call it a double bar R. Everything's got double bars in it. It's literally, I just draw an R and then just add an extra line in it. Either line outside or line inside. I think the line inside's easier. When you write this, technically you should put it in set notation, which means fancy brackets outside of it. Those are the ugliest ones I've drawn. The fancy brackets never go away. Sorry to tell you that. Now your range, okay, first of all, it will vary. But will always, underline the word always, be based on integers. So our parent function, this original one I gave you, its range, you would write all integers. Because you're going to hit every single number, whole number there is. There's also a symbol for this one if you'd like to know it. If not, you can just write all integers. Does anyone want to know what the symbol is? You're just going to write it. Anyone interested? Okay. Integer seems wrong. You think real starts with R. That makes sense, right? It's not I. You would think it'd be I. It's not. Integers they're all double barred. It's a Z. It's a double bar Z. I just make a regular Z and then extend the top to make my extra line. So I just made my first Z like a normal Z, and then I just extend the top to make the extra line in the middle. So every time we do these, every time we solve these and want to graph them, because they're going to make you solve them and graph them, you have to first make a table. Number one. Then you're going to graph it. Then you're going to state the domain, the range. Every single time, no matter what. And I'll show you how to do that. Because the table's just a little funky. That's where people get confused. So make a table, graph it, and I'll show you how to do that too. And then domain and range. Okay. We got this. We're ready to graph. Okay. The good thing is it's not so bad. Okay. I'm just gonna give you an example. Best way to do it is just jump in. Okay. First example. This is our function. F of x equals the greatest integer of, to the symbol for step function. We're going to write on the inside x plus 2 and then close your greatest integer bracket symbol. Okay, so that's our function. That's it. Now, we have our picture. Now, to make our table, this is going to feel very strange to you. Normally, you just do x and y, yes? When you do x and y, you need, it's going to be real strange, you need double the amount of space for x that you normally do because we're going to put inequalities in there. So don't line it up next to your like holes on the left or you will have no room. Ooh, because Didn't we learn just a little bit ago that every number between 0 and 1 rounds down? So in our table, we have to show that every number between 0 and 1 goes to 0. Every number between 1 and 2 goes to 1, and so on and so forth. So I like to do at least one negative, because it's your option. So start at -1, less than or equal to x, because it's any number we want, less than, what's the number that's right above 0? That 0. That's a little smushed. These all have the same answer. Everything we round down to will have the same answer. We're going to do at least 4 of these. So now we're going to move up between 0 and 1. The number on the left always has the equal to. The number on the right always just has the less than. Because remember, we round down. We round to the left. So between 1 and 0, 0 and 1, 1 and 2, and then 2 and 3. What's the difference between less than or equal to and equal to again? Or what's just the difference between equal to and less than or equal to? What's literally the difference between those two symbols? Oop, I literally just wrote it twice. That one. Visually, what's the difference? One has a line underneath it and one of it doesn't. With the words less than or equal to, less than. So one of them says or equal to. This one includes something. That's why it's on the left, because our answers are always the lower number. This one stops that number. That's our stopping point. Because if I said everyone in this room, including me, is less than 30 years old, that means we can be 29 or less, right? I had to pick a higher number, right? Because I'm old in comparison to the rest of you, right? But if I said everyone in this room is less than or equal to 27, is that still a true statement? Yes, because how old's Miss Rinaldi? Take a guess. 27. So it's still a true statement. Equal to includes that number, less than does not. So that line means yes, that number counts. So you literally only take the left number in each, and you're going to plug it in to the equation. By picking a whole number, these brackets really mean nothing. This means you should pick a number that's a decimal, but why make it hard on yourself? So if you always pick the left number, -1, what's -1 plus 2? 1. No matter what number I pick here, every number I add between, like this would -1/2. -1/2 plus 2 is -1.5, but you round, right? We're rounding, and it'll be the same. So here, always pick the left. 0, plug 0 in. 0 plus 2 is 2. Plug 1 in. Plug 2 in. So the math itself is very easy. These symbols, the greatest integer symbols, really just mean how you set up your table. That's all that means. Okay. Now see how these are connected here? That's how we're going to graph. So since our x's start at -1 and our y's go from 1 to there, I just make a graph only in what I need. So I only need x is 1 all the way to x is 3. So I just made a top chart because I don't need the bottom half, right? Because none of my y's are negative. And then I'm going to extend that, and then I'm going to go up 4. 1, 2, 3, 4. If you need to label them, go ahead. My -1, I plugged it in. What did I get as an answer again? 1. And I could choose that answer because it says equal to. When you choose something, that's a solid closed dot. So I'm going to make a closed dot at -1, comma 1. -1, comma 1. Okay. Made a closed dot. But what is -1 connected to? All the way to what? To 0. 0. Is 0 included in that number? Right there. It says x is less than 0. No, it's not included. If it's not included, it's going to be an open circle. So we're going to plot that point 0, comma 1 because they're all on the same line together. So x is 0, comma 1, and I'm going to make it big enough so we can try to see that it's an open circle. It's hard when I'm using marker. It is an open circle. You try to use spit. It's hard. Open circle. Better. Okay. Then, since these are connected here, we're going to connect only those 2 points. I know one is way bigger than the other. It's just because I wanted you to be able to see it. Now, when we move down the table to a new line, we need to make a new line on our graph. So every single one's going to look like a little step, and you'll see it once the picture goes. The next line, it says 0. What was its answer? So we're going to start at, does that make sense? Okay. So you start at x is 0. We're going to go up 2. That's going to be a closed circle. Same line, 1, comma 2. So 1, comma 2, that's an open circle. That one's much easier when they're not on a line. Since they were connected in my table, they need to be connected in my picture. Keep going. Next line, 1, comma 3. 1, comma 3. First dot is always closed. 2, comma 3. You're going to be in my way. Last one, 2, comma 4. 3, comma 4. Barely made it. So just imagine a little guy. What do those look like? That's why it's called a step function. It literally looks like steps. Now we picked these numbers, yes? Could I have picked any numbers I want? I could have picked all these negative numbers over here. I just didn't. I could have picked any positive numbers I wanted over here, couldn't I? We just didn't, right? So when you graph these, you have to think about what would be happening. This would continue to go up, wouldn't it? Slowly. What would happen this way? It will continue to go down, which is what you have to think about when you think about domain and range. So the domain is always, because look, left to right, there's never a space between the x's, because remember we talked about this for functions. Can you have an open dot and a closed dot on top of each other? Does it still make it a function? So that's okay. So this one is always going to be all real numbers, and I'm going to draw the R. I put 2, it helps to put 2 bars and then the R. Double bar R. And then for range, again, fancy brackets, look at your Y values. Literally look at your table. The table is actually easier. What do you go up by every single time? You go up by 1. So we're going up by, what are they called? What are whole numbers called again? Starts with an I. Integers. So you can either say all integers or you can draw a Z with a double bar. I now have blue hands. Does that kind of make sense? Or yes, it makes sense, or you definitely need another one. Okay. So we use this for reference. Example 2. Your function is going to look a little different. F of x equals I'm going to put a 2, so 2 times the greatest integer of x. This is just going to change our range. So 2 times the step function of x. Okay? Again, once you have your function, now you know how much space to make for your table. Always make your table. I would always pick the same 4 intervals every single time, never change it. So -1 is less than or equal to x less than 0. 0. 1. 2. Every single time. Never change it. Now, what number again are we going to plug in when we're doing the math? Left one, first one, right? -1. -1 here, just a whole number. This means, is it a whole number? Yep, already good. What's -1 times 2? Done. 0. What happens to 0 times 2? 0. Take a left number. 1 times 2. And then last one, 2 times 2. So now, our number's going up by 1 this time? No, so it's going to change our range answer. That's the only thing it's going to change. Our graph's going to look different. Range is going to be changed. That's it. Okay? So, let's graph our graph. Y's are the same. We can do the y's the same. And look, the x's are basically the same too. Not the one. Yeah. Oh, perfect. Oh, I am going to have to go down a little bit, aren't I? For -2. Y's are almost the same. I'm going to have to go down. And if you notice, it might be helpful to space your lines out instead of putting them really close, which is why I did not suggest using those graphs I gave you, because you can't really read them on those grids. They're too close together. So now let's plot these. See if you get the same step kind of function that I get. See what's happening to your stairs. Oh, I did that at 1. Silly me. Hands need cleaned. I'm making mistakes with my own fingers because they're too difficult. You don't know the answer for domain. See if you could try to think about what you would write for your answer for your range. You would describe those numbers. That's why we use pencils. If we make a mistake, we can erase it. Well, mine's a little smeared. Did you kind of get the same answer as me. You just got bigger steps to go through. Wake up. When they're on the x-axis, sometimes they're hard to see, right? They just look like dots. So, anyone have a guess for your range? Again, the graph's nice, but the table really does tell you the answer. It's really helpful. Anyone have a guess? They're all integers, but what kind of integers are they? They're even integers. You literally can write even. You can either write the word integers again, or you could use a symbol. Your range answer is even integers, because they go by 2. If they went by 3, you could say integers multiplied by 3. You'd have to then just describe what you're literally doing. But yeah, even integers or odd integers, right? You can use those words. Did we get the same-ish picture? Other than mine smeared and crooked. Yeah, Isaiah? Lila? Not hard? Yes, hard? Pretty easy? Thing is, if you can do this and remember what this is, you can do the rest of it. Right? That table sets a tone for everything. Both of these special functions, the table sets the tone. This table is specific. It looks just like this. Piecewise functions, which I'm about to show you. Completely different table, but it sets the tone for its graph. Okay? Are you ready to move on to a new kind of graph? Okay. Okie dokie. So let's talk about what a piecewise is first. I'm going to try this way, see if it helps. So piecewise function. So piecewise function includes 2 or more expressions on one graph. Each expression, I'm going to abbreviate that, applies to a different interval of the function domain. I'm done. So a piecewise function that only has 2 of them looks like 2 rays on a graph. Do you remember what a ray is? This is a throwback. Do you remember what the definition of a ray is? What a line is, right? A line has 2 arrows on the end, 2 points in the middle. And then there's a segment, and then there's a ray. Do you remember what a ray is? Middle school math. A ray is a point connected to an arrow. It still has to have another point on it somewhere. And that point can be open or closed. It's like half a line, basically. Okay, so this is what a piecewise function looks like. F of x equals. Now what you're going to do, you have two lines, right? F of x like on a top line. You're going to make a bracket, but you're going to make it big enough basically on two lines on paper. I'm writing on a whiteboard, so I don't have any lines. You always do this. When you get used to it, sometimes people like to center. I'm going to erase that line because I don't like it. They like to center their f of x. Okay, now two different expressions. My top expression is going to be negative 2x. Then you're after that leave some space, right? If x is greater than, those are not going away either, 1. That is one expression in one interval. Next expression is going directly underneath it. X plus 3 is that expression. You again write the word if, then you'll get another interval. This one is x is less than or equal to 1. Every single time, these expressions will change, these numbers will change. If will always be there. This is a piecewise function. It means two pieces make the same graph. Okay? A table starts off just like a normal old table. You're still going to want to find 4 numbers. You're going to pick 4 numbers for your x's. You cannot just randomly pick them. They have to be based on your interval. So this top one, you basically, I just need a piece of something. My phone's right there. I look flowers. You look at one at a time. So if you just look at the top one, this interval says x is greater than 1. You always pick this number. So I'm going to write down the number 1 in my table. Now you need to pick a number that is true to this inequality. What's a number that's greater than 1? 2. I always pick the next number up, right? So I have 2 numbers for this interval. Every time I do that, I then draw a line because that's my 2 numbers for the top one. I'm going to just look at the bottom one. Now we're going to pick 2 numbers for this one. You always pick this number. Mr. Ronaldo, we already picked this number. It's okay. Because you notice the inequalities, one of them was greater than and one of them had to equal to. So it's okay because we have an open and closed circle. So what's a number? We're going to first pick this number. So 1. Then you pick the next number that follows this rule. So x is less than or equal to 1. 0, because it's less than, because we already picked the equal to 1. So we're still making our table first. Now, since we have 1s in both of them, we have to know which one's which. This inequality sign on the top one, does that represent an open or closed circle? An open. So next to that one up here, I'm going to draw an open circle. Now, we picked 2, right? Could we literally have picked any number? We just chose 2 because it was easier. So since we picked 2, but we could have picked anything we want, we're going to draw an arrow. That means that our arrow is going to go towards that number when we're done. Now we're going to do the same thing in the second group. That 1 was in the problem. Open or closed circle? Closed. Again, we picked 0. We could have picked any number less than 1. So what are we going to do? Draw an arrow. Normally, these arrows go away from each other, but this is greater than, less than. They're just in a mixed order. Now we literally do the math. Since these numbers are from the top, you can only plug them in up top. So you take 1, plug it into the top expression. Plug 1 into the top expression, was negative 2 times 1. Negative 2. You just do some math. This 2 we picked was also for the top, so take it, plug it in. Negative 4. Negative 2 times 2 is 4. Negative 4. Okay, now that we crossed the line, that's why I draw the line there. Now all the numbers we plug in have to be into the bottom. Take 1, plug it in, what do we get? Positive 4. Take 0, plug it in, what do we get? Okay, so these numbers are all completely different from each other, aren't they? So when we graph it, we're going to need, we got all positive x's, but we got negative and positive y's. So I just draw my graph always based on what I have. So I have all y's, but I only need positive x's. Just draw what I need. Right? So then x's, 1, 2, y's, 4 each way. 1, 2, 3, 4. 1, 2, 3, 4. Always start with the dots in one at a time. So do this top section first. Always start the dot. The point 1 comma negative 2. So 1 comma negative 2 gets a open circle. What I would do is I'd plot the point for the next one. So 2 comma negative 4. So plot the point 2 comma negative 4. Comma negative 4. Those are the only two numbers that go together, right? What did we say we had to do when we were done with that when graphing it? Draw the arrow. So start the open circle and make an arrow through it. That's one piece of the puzzle. No, it's just on the line. So I always make the open and closed dots at the beginning of my sections big. The rest of it's just normal. Okay, now the second section. This one's a closed dot. 1 comma 4. I always make it real big. I don't know why, but so you can see and also so you can see, oh, that's my starting point. And then 0 comma 3. 3. And then I'm going to put my line through it because I'm going towards that 3 away from my dot. I would 100% pass that point. You see how when we were drawing normal graphs, I told you to pass your graph. You see how I still passed my graph? That's my judgment of character. Now, do you notice that this line's going this way and this line's going this way? So are my actual lines ever on top of each other? You did something wrong if you ever get your lines on top of each other, okay? That means you probably drew your arrow the wrong way. They should never be, your points can be on top of each other. This is like star note forever. Lines can never be on top of each other. Your points can, open and closed. Lines never. So they never can, so like these both couldn't go this way because then y is vertically, right? They wouldn't be a function because they wouldn't pass the vertical line test. Yes. And one could be straight and one could be going down. This one could be going up and this one could be going up, but since they're going left to right differently, that's okay. Left to right, they need to be different. Now, the hard part in these, other than drawing your arrows the right way, is the domain and the range. Okay? Now, it's always based on the picture, which is why I draw my lines as far as I can. Your domain is talking about your x values. Yes, we have talked about this before. I always start at my points. My points share a spot, don't they? From my point here, doesn't this one go forever this way? And my point down here, doesn't it forever go this way? So am I skipping any x values? So what do you think we're going to put for our domain? All real numbers are double bar and then bar. Yes, all real numbers. Now the y's are the hard ones. This is what I like to do because the table doesn't help you. The picture's what helps you. Sometimes it helps because you know how you can go like this with your hands to take your y and turn her to help. Look at one at a time. Start left to right. This guy, doesn't he cover everything this way? Okay, so this part's all covered. That's nice. This guy starts here and then goes down. Does he cover anything up here? No. So we need to describe that it starts here, but this line covers everything down. This line covers everything down. So we need to describe that our highest point is this number, and we can cover everything below it as an inequality. What's the y value at that point? Y value, sweets. Yep. So what you're going to do is you're going to put range is, and then you put your set builder bracket. Y is, open or close circle with that. So I'm going to write, and it's less than, right? Everything underneath it works. So we're going to write less than or equal to, and then Ty said 4. That is your range. So the range is the hardest part, which is why extending your lines really does help. It helps you see it. Does that make sense a little bit? You just have to practice it. Okay, we'll do another one. I'll change colors. I'm not using blue this time. I'm staining my fingers. We have time for one more. That's how long this kind of takes. Okay. Here's another example. How about, I'm going to show you this guy. So f of x equals, and then again, one bracket. You never do a second bracket. This is just saying all of this makes that function. That's what that means. The top expression is 2x plus 1. Then you write if x is greater than 0. The next expression just says 3. No x. If x, oh, I switched those. Your inequalities should point the other way. That was my bad. You can't read. X is less than 0 for the top, greater than or equal to for the bottom. That was my bad. You can't read. So less than on top, greater than or equal to on the bottom. If you ever repeat numbers, one has to be equal to, one has to not be. If not, they did something wrong. Okay, so now let's make our table again. We need 2 numbers each, so we'll need space for 4 numbers. What are the 2 numbers I'm going to pick for this top expression based on that inequality? 0, of course, and x is less than 0. -1. I always put them in least to greatest order, so I'm going to put -1 then 0. It is a preference thing. It's up to you. And if you want right here, you can always put your open or close circle now. That 0, open or close circle at the top. Open. We picked -1, but could have picked anything, which means the arrow goes towards it. Now do the same thing for the bottom. What's the 2 numbers we're going to pick here? Have to pick 0. Sure, 1's fine. Could we pick anything else we wanted to? Sure, why not? But we picked 1 because why not go in order? This 0, open or close circle. Close. What am I going to do with the 1? Draw an arrow towards it. Based on that inequality line that's underneath there. Okay? Greater than or less than means nothing. It's all about the inequality line. So now plug them in. Take -1 and plug it into that top equation. -1 times 2 plus 1. -1. You just gone backwards because you're plussing a negative. 0. Plug 0 in. What do you get? Don't shout it if you don't think. What's it? 1. Okay. This section, is there anything we can plug x into? It just says the answer is Literally, when there's no variable, the answer is just whatever it is. So that means that one's going to be a straight ray. It's just going to be go straight on 3. It's going to be like a horizontal line. Okay? Now, let's make some room to graph it. Need a little bit of negative x's and a little bit of negative y's. Okay, x's, I just need 1, 0, and 1. Oh, that's x's, not y's. Grab, bless America. Then I'll tell I need to go home. Okay. Y's. Now this is. Always do the top section first, put it all together. 0, 1, 0, 1, open circle, -1, -1, regular point. I could have picked anything I wanted, so I'm going to go towards that point and through it. Try it and see if you're getting what I'm getting. Does that make sense, Michelle? Okay. Then 0, 3, 1, 3. So that's right next to it. So since I'm going to go straight to that. This one's a funky one. That's why I gave it to you. So just in case it's on your homework, you have seen it. This one, domain, again, should still be very easy. Because again, look here. Does it cover everything this way? Look there. Does it cover everything that way? Range, I'm going to need way more room. So if we look at the range, turn her sideways. The range is weird, isn't it? Because this bottom one says, I'm starting here, and I'm going to cover everybody underneath. Nothing up top, just underneath. This guy says, am I going anywhere with my range? No, he's only hitting what number? 3. He's only hitting 3, and this guy is hitting what number and everything less than it? 1. We have to literally describe that with an inequality. So you write, I always write the lower thing than the greater thing. So describe the bottom thing first. So you say y, and it's going down, right? And it's an open circle, so it's just less than. Again, what's the y value there? 1. And it's doing something else, isn't it? So you literally write the word and. And then what's it doing up here? What does y equal up there? And it doesn't change, does it? So you literally write y equals 3. You're just describing it. And if it does help, always turn it sideways because the x's make so much sense because you can see it. So the y's, do not be afraid to turn her around if you need her. And then, of course, you would close your fancy brackets. Okay, does that kind of make sense? Practice it. You don't have a lot of them. I didn't give you a lot of homework because they take some time, right? Try all of them. Me and my Irish proud colors I got going on my boards, right? Try them. If you have any questions, make sure to ask them tomorrow. We will do practice problems tomorrow. Okay? Yes, after I answer your questions. And then